Hello there! Today I'm starting a new video series on Service Mesh. Each video in this series will cover a Service Mesh topic, short and to the point. My plan is to limit the length of each video to around 10 minutes where possible. The first question is, why Service Mesh? The need comes about because of microservices. Let's look at the benefits of microservices to understand why they're so popular in the cloud-native world. Agility. Microservices deliver updates faster and react faster to new business demands. Because each microservice is independent of the others and is self-contained, that means you can dedicate a very small development team to develop a microservice without affecting other microservices. Highly scalable. You can scale individual microservice easily, for example, using OpenShift. Compare that with a monolithic application. You have all the services included in the monolithic application. That means when you scale, you have to scale the whole monolith, which is less efficient. Can be purpose-built. You can use whatever programming language to develop your microservices, depending on your skills and also the need to use particular programming language. For example, if you're programming AI, probably you'll be using Python. Resilience. Because each microservice is independent of other microservices, that means when one dies, it's not going to affect the other microservices. And because of the benefits of microservices, a lot of organizations are migrating their legacy monolithic application, refactoring them into microservice-based applications, resulting in more microservices. Microservices are not without their own challenges. For example, tolerance to faults. Because an application may be calling a number of microservices in sequence to complete a particular task, so a failure in one microservice may lead to cascading failure or partial outages. Communication. Now that you have so many microservices and the microservices need to communicate with each other, that means network latency, concurrency, etc. will enter the picture and present challenges. And you have so many microservices, you need to be able to secure them. Because you have so many microservices now, that means the failure surface has increased. And also version incompatibility become an issue. Because there's so many microservices, it becomes more difficult to monitor their performance and also give you a good picture of how your applications as a whole performs. And each microservice will have its own log. That means all the logs are scattered, and you need to aggregate them to give you a complete picture of how your microservices or your applications are running. Here are some of the features that can help you meet the challenges of microservices. The features in blue have already been provided by OpenShift. For example, auto-scaling, container build, automation using, for example, S2I, distributed logging. The features in orange have also been provided by OpenShift, including blue-green deployment, canary deployment, stage rollouts, etc. But these features provided by Service Mesh give you a more refined and finer-grained control over these deployments and rollout strategies. We'll come to that in subsequent videos. Now let's have a look at the world without Service Mesh. See all these orange boxes? these are the features that are required to meet the microservice challenges. Like these challenges include security, tracing, circuit breaker, routing, service discovery, config, etc. When your developers develop an application, in addition to the business logic for the application, they have also to program security, tracing, etc. into the application. That means it takes a lot more time to develop all these cross-cutting concerns. It's true that you can find a lot of libraries that can help you do this, and depending on which programming language you're using, you may or may not be able to find such libraries to meet your needs. Now, let us look at the world with Service Mesh. So this is the world. Without Service Mesh, you still have all these orange boxes. Now, the world with Service Mesh, all these orange boxes disappear. That means your developer no longer have to develop all these features, include all these features into your programming code, because you have dedicated all these tasks to Service Mesh. Service Mesh help you to connect these microservices together, control them, provide you with observability using tools such as Prometheus, Grafana, and Kiali, and provide you with distributed tracing using Jaeger. Now let's have a look at where Service Mesh sits in the OpenShift stack. So at the bottom, you have the infrastructure, like it could be the cloud or on-prem. And then on top of your infrastructure, you're running OpenShift. And Service Mesh actually sits between OpenShift and your services. Let's have a look at the architecture of Service Mesh. It consists of a data plane and a control plane. The data plane is composed of a set of intelligent proxies or envoy proxies deployed as sidecars that mediate and control all network communications between microservices. And these are your applications, and these are the sidecar envoy containers. The control plane is responsible for managing and configuring proxies to route traffic as well as enforcing policies at runtime. You declare your policies using CRDs or custom resource definitions, and Istio-D will distribute the configuration for these policies to your sidecar envoy proxies to be acted upon. And you can also plug in additional tools such as Jaeger for distributed tracing and Kiali for observability. In this video, I describe why you need Service Mesh. I also describe its architecture. In the next video, I shall be talking about how you can apply the security features of Service Mesh to your applications. Until then, stay safe and take care.